Okay, so example 3. A 0.2 kilogram tennis ball strikes the wall horizontally with a speed of 100 meter per second, and then it bounces off with a speed of 70 meter per second in the opposite direction. Now we have to find the magnitude of impulse delivered to the ball by the wall. And then if the ball is in contact with the wall for 10 milliseconds, determine the magnitude of average force exerted by the wall on the ball. Okay, so let's try and draw the situation here. So we have a wall, something like that, and then we have the ball being striking the wall horizontally with a speed of 100 meter per second, and then it bounces off in the opposite direction. So it is still going horizontally, just at the opposite direction. So this one would be just v 70 meter per second. Okay, and then let me write u ball, v of the ball, and then we know that the ball is staying static, so it should it should be just 0. The wall is 0. Okay, so now we have to find the impulse. Okay, the impulse delivered to the ball by the wall. Okay, so how do we calculate that? Is we can use impulse punya formula, which is sorry, forgot pula. Where is it? Okay, this one. So impulse is delta P. Okay, it is the change in momentum. So delta P is the change in momentum. This one, delta P. So it is also the change in momentum. So we can use that. We know that momentum is equal to m. Since this is the change in momentum, how do we? Okay, I do like this, mv minus mu. So we can simplify this for the ball. V of the ball minus u of the ball. Okay, so this is the impulse on the ball. Okay, so mass of the ball is 0.2, velocity of the ball is 70 minus, velocity is a vector juga. Okay, so since the velocity of the ball yang untuk after it strikes the wall, it is going to the left, which is negative direction, so we have to put negative 70. Okay, so minus 100. Minus ni memang minus sini lah, 100 ni positive sebab the velocity is going to the right. Velocity after they strike the wall pula pergi left, so that's why kita put negative 70. Okay, so you'll then get the impulse to be negative 34 Newton second. Okay, so that is A. That is the magnitude of the impulse. The negative here is only telling us the direction. Okay, it's not the value, it is the direction. The magnitude is just 34. Okay, now if the ball is then in contact with the wall for 10 milliseconds, determine the magnitude of average force exerted by the wall on the ball. We know that the average force can be calculated using this equation. Okay, so this one, J is equal to average force times the change in time, ataupun the how long they are in contact. Okay, so J is equal to average force dt. So we have 34 as the impulse, and then FAV, the time is 10 negative 3. So we then have the average force to be 3,400 Newton. Okay, so that is on example number 3.